Okay, hello guys, I just hope you are doing well. So in this video I will be doing electrostatics, whereby you should know all these equations. This one, yeah. So if you can understand all of these equations 1 2 3 4, your life will be much more easier, yeah. Also this topic, it's one of the easiest. So this equation, you only use it if they say to you calculate the charge after separation. If they say calculate the charge after separation, this is the equation that you will use, whereby you will add charge 1 and charge 2 and divide by 2 there. And this one equation, it is the equation of charge quantization there. The name of this equation, it is the charge quantization, whereby if they give you the number of electrons, you should understand that QE, it's a constant number there. This one, which is 1,6 multiplied by 10 to the exponent negative 19 there, columns there. This one, you'll get it at the back of your formula sheet, by the way. This, you'll get it at the back of your formula sheet. If they give you electrons, you'll multiply those electrons in order for you to get a charge there, which is a charge quantization. And also we got this equation, by the way. This equation then, if you want to get a change in charge, or you can call this thing difference in charge there. So something like this there. Here they will give you a charge there. Let me say this thing is charge A and this one is charge B. And those two charge, guys, they will brought in contact there, meaning that they will combine them there. They will brought them in contact, something like this there. Then after they brought them in contact, they will separate those charge there, which is charge A and charge B. They will separate those two charge there. So this charge, guys, if they give you maybe it's 5, you'll find out here that charge will become 2 columns there. From here it will become as 2 columns there. So in order for you to get a difference in charge, this is the equation that you'll use, whereby you'll say final charge minus by initial charge, meaning here it's a final charge minus initial charge there. This is where you will use that equation, meaning that charge, guys, it's also called a difference in charge, meaning from here until there you'll get a difference in charge there. That is the equation that you will use there. And also we got this equation, which is also called a net charge here. Net charge, or you can call it as a total charge. So this equation, guys, you use it whereby you will add both of the charge there. Maybe this one, I will say this one is charge it's 9. Then that charge there will become 2 there. So after those two charge, guys, they brought into contact and they separate, they will have equal charge, and that equal charge is the one that we call it a new charge, that one. For you to get that charge there, you will add those two things, you divide by 2 there. Okay guys, so now let's go from here. A key thing that you should understand is that electrons, guys, they move from negative charge to positive charge there. So here our electrons, this thing is a symbol for electron, guys. Take note about it. That one, it's a symbol for electron. Electron, they move from negative to to positive charge there. From the negative charge, guys, we got what we call excess of electrons, meaning that we got more electrons there on the negative side. It's what we call excess of electrons there. This is a symbol for electron. We got an excess of electrons there, meaning we got more electrons. Then on the positive side there, we got deficiency of electrons there, meaning we got less electrons here. That's why electrons, they will move from more electrons to less electrons, deficient electrons there. And guys, there are these things that you should also know them. These nano, gano, micro, this one, it's what, it's mini something like that, guys. All these things, by the way, you should know them. That when you see n, that n, it represents 10 to the exponent negative 9, and this one, it represents 10 to the exponent what, 9 there, and this 10 to the exponent negative 9. All those things, guys, you should know them by heart there. You should tram them, by the way. But a key way that you can use there, you can even use this word there. You can even create your own word if you want to. But here's my own word there, which is gumamkhulu. Gumamkhulu there. So it's up to you which way you will take it, that thing. But this is the only way that I use there. Gumamkhulu. So that thing, what does it mean? It means that our n there, it's a nano, which got a negative 9 there as an exponent. Then that g, guys, it's a gano, which got positive 9 there as the exponent. This one, it's a micro, which got negative 9. So just like this one, it's a kilo. This one, I know this one is kilo, but these two of them, I kind of forgot them. But you as a learner, make sure that you know that thing. So let me go straight to the questions. Here you are given a question which Sim will say, I hope you can see most this question with no doubt. So here's a question, guys. This question Sim will say is that two identical conducting sphere A and B carrying charge of, you see this one, it carrying a charge of negative 2 nanocoulombs and positive 5 nanocoulombs respectively, come into contact with each other and then separated back to their original position. So these two charges, guys, before contact, they were like this. So they contact those two charges, then they become like that, which they didn't tell us they are charged now. Now the first question symbol says they state the principle of conservation of charge in words. Please, guys, trim that definition there. I'll drop the definition in the video there. So calculate the number of excess electrons on sphere A. So they say that calculate number of excess electrons there. Excess electrons. So remember what I told you, guys. When you see excess electrons, it means that you got more electrons there. They need you to calculate a number of excess electrons, meaning more electrons on what? On sphere A. That thing, it's a negative charge. It got more electrons there. That's why it has a negative charge. This is how, guys, you calculate that thing then. Remember there, I show you equation like this, which is NQE, whereby I told you that it's constant. You get it at the back of your formula sheet there. Just something like this there. So this is how you do it. We are referring on what? On charge A. So, and there is charge A, electrons for charge A there. So now what I will do, I can even here, let me just do something like this there. Because, guys, I want to solve this thing. It means that I can make this thing to represent my equation there, meaning that I can divide by this thing both sides there. I can divide by this both sides, so that equation now will become cancel. That equation now will become something like this now. It's NA, and this thing will be QA over what? E. So meaning now this is the equation that I can even use there, which is my NA there. It's equal to divide by this. So now I can substitute there. I know the charge there. The charge that I'm given there. But remember, guys, I told you something there. From that word go mam ko. So from that word, guys, you should understand that something which is here, it's nano, here it's gano, and here it's micro, and this one, this it's n, m, yeah. This is how you form those numbers, guys. You start from 9 there, you decrease by 3. You decrease by 3 there until you reach 3. You decrease by 3. Do you see? You start from 9, you decrease by 3, you decrease by 3. Then the first number should have a negative number there. should be negative, just like this there. Meaning that when I see this thing, when I see this one, it means that thing it's 10, negative 9. Something like that, do you see? So this is how, guys, I will substitute this thing. Do you see that one there? This is how I will substitute there. I will just, and guys, in this equation there, you just substitute this thing as positive there. Just substitute there. You don't include negative sign. That thing it's positive, multiply by 10. Because it's nano, it means it got negative 9 there. Then divide there. This thing there, it's 1,6, which is this, minus by that. So now you can get your what? Your final answer there, which is now your electrons there. You will press that thing on your calculator. This is how you'll press it there. So today, guys, I just come with a black calculator today. So divide this, comma this, and multiply that by negative. This is what I get there. So which is 1,5 then multiply by 10. Then you can say electrons. So those one are the excess number of electrons for charge A there. For charge A, or if you feel that thing inside there, that thing is still straightforward, you can even use that equation in a normal way there. Then you just substitute them, whereby you are given that charge, which is 2 multiplied negative 9, and this one there is the one that you want to solve. This, you know it. Multiply this thing to the 10, and here it's minus 9. Do you see? And now you can divide this thing both sides like this there, and divide by that thing the both sides just like that there. So that when you divide by that thing, this will cancel them, and that equation now will still become like that there. You'll press that thing on a calculator to get your final answer. So don't think, guys, this thing is hard. This thing is a straightforward thing there. Yeah, here I just make that thing to represent the equation, then I substitute to get my final answer there.